Fine.
This meeting is being recorded.
A very good afternoon to all of you. On behalf of Department of Computer Science and Engineering, NIT Raipur, and 4th International Conference on Machine Intelligence and Signal Processing, I welcome all the dignitaries, respected session chairs, and participants. Before we start the session, let me introduce our esteemed session chairs. Our first session chair is Mr. Ramchandra Gurjar. Mr. Ramchandra Gurjar is working as assistant professor in SGS ITS Indore. He completed his B and ME in year 2001 and 2006 from RGPV Bhopal. He has guided more than 40 master's theses. He has published more than 50 research papers in reputed journals and conferences. Our next session chair is Dr. Gyan Singh Yadav. Dr. Gyan Singh Yadav is an assistant professor in the Department of Computer Science and Engineering at IIIT Kota. He received MTech and PhD from the Department of Computer Science and Engineering of IIIT DM Jabalpur. He has published several research papers in journals and conferences of international repute. His research interests include cryptography, steganography, and cybersecurity issues. And we have Dr. Sarsis Tripathi as our next session chair. Dr. Sarsis Tripathi is currently working as assistant professor in Department of Computer Science and Engineering at Motilal Nehru National Institute of Technology, Allahabad, Prayagraj. He received his PhD and MTech from MNIT Prayagraj in the year 2013 and 2008 respectively. His research interest area is artificial intelligence in IoT, security in real-time system, and wireless sensor network. Thank you, sir, for joining the team. May I request all the session chairs and participants to turn on their video.
Sir, we welcome you, sir. We are very much happy for accepting our invitation and being the part of our conference MISP 2022. Sarsis, sir, thank you very much. And Gyan Tripathi, sir, Gyan Singh, sir, and Gnaneshwar Singh, sir.
Thank you, sir. Thank you.
Thank you. Thank you, sir. Yeah, you can invite the first participant, please.
May I request first all the session chairs. In this session, we have 5 papers to be presented, and I request all session chairs to greet this session. Sir, your voice is not audible.
Yes, now I think I'm audible.
Yes, sir.
Yes,
Okay,
sir.
fine.
Now you are clear, sir.
Okay, thank you. With the permission of other session chairs, Dr. Gyan sir and Dr. Ramchandra Gurjar sir, can we start?
Sure, sir. Sure.
Sure, sir. Am I audible,
So,
sir? I am RC Gurjar. Am I audible?
Yes.
Yes, sir, you are audible. Fine.
Okay. Okay, sir. Start, sir.
So with your permission and all the dignitaries present over here, I would like to call Ms. Pallavi Joshi first for presenting his work with paper ID number 99, and paper title is Distributed Data Fusion Approach to Mitigate Node Redundancies in an IoT Network. Ms. Pallavi, are you there?
Yes, sir. Sir, am I audible?
Okay, yes, you are. You can proceed. You are audible.
Okay. Sir, my slides are visible?
Yeah, visible.
Yeah. Okay.
Visible.
Good afternoon, everyone. I am Pallavi Joshi, and today I am going to present my work, that is a distributed data fusion approach to mitigate node redundancy in an IoT network, paper ID 99. And these 2 slides are about my institute, as it is compulsory to include. So these are the table of contents. Background. My title is about finding node redundancy in an IoT network, and WSN is like a subset of IoT. Like WSN is like a component. So the sensor nodes, the network which consists of sensor node is called WSN. And in many application, it is seen that this WSN technology faces many challenges and issues. One of the challenges redundancies at a data level, at node level, as well as at network level. My work focuses on clearing these redundancies at the data level. I have to identify those nodes which are redundant by the help of identifying the redundancies at data level. So it is like a two-tier system. So in this, I will be using two techniques. That is a kernel density estimation based method, which uses Pearson divergence, and another is a bacterial foraging optimization along with ELM. So optimized ELM. So this is the literature survey. First paper is on combination of BAT and ELM, BAT algorithm, optimization algorithm, and they have used this for doing data fusion to remove data redundancies, and they achieved low energy expenditure as well as high surviving nodes. Sorry. And high number of surviving. Sir, actually my slides are not visible. That bar is coming in which the participants are shown. So, hello.
But we are able to
Madam, you can drag it.
see
You
your
can
slide.
drag it to the bottom of the screen.
What?
There is on the right top corner, there is a view tab
Okay.
where you can
Yes.
select
Yes,
side by
sir.
side gallery.
Yes, sir, I got
Okay.
it. Thank you, sir. Second paper is it is using data fusion using gray model and optimally pruned ELM, extreme learning machine technique, and it gives high successful prediction rate and the less running time as compared to the gray model least square support vector machine technique. Then third paper, it deals with using Pearson divergence, and it only focuses the removal of redundancies at data level, and it makes it as a intrusion detection model for WSN. It gives better divergence classification as compared to Rennie's entropy method, and achieves 97.24% detection accuracy for low false positive rates. Then the fourth paper, it uses it focuses on the distributed segment based recursive kernel density estimation using KL divergence, and it is known for using these technique at lower communication cost, and it achieves high accuracy as well as at low false positive rates. Then fifth paper is about using Mahalanobis distance-based radial basis function applied to ELM network, and it uses Kalman filter to remove the noisy data, and it achieves low energy consumption as well as high training and testing accuracies. Then a sixth paper is about it also does data fusion using a fuzzy logic controller, and it also removes low quality data from the network and achieves successful data reception and low energy consumption as well as high throughput. And the last paper, it uses data processing at node level to remove the redundancies using the mobile agent technique, and it enhances the network lifetime and minimum data fusion cost. So above these, all these mentioned methods, they focus on lifetime enhancing as well as energy, as well as reduction in energy consumption, but very few methods focus on enhancing the accuracy. So my work emphasizes on this aspect. And I am using, as I said, I am using the kernel density estimation in combination with the Pearson divergence to calculate Pearson divergence between the two data points. And after that, this BFO ELM network is this the redundancies at data level are being fed to the optimized DLM network for further processing, and at node level, those nodes which are sensing the redundant data or some anomalous data, they are identified and classified. And this is the overview of the proposed method. So the network is randomly placed, and the clustering used here is the k-means and self-sum optimization clustering, self-sum algorithm. And then this deployed network is fed into it as it is a distributed network, since cluster heads are used and only one base station is used. So this is fed to the mechanism which I told, Pearson divergence method, and then it calculates the density of two sense data at two different time instants and construct the covariance matrix from the data set, and then update that matrix. And it by the help of that, it um, uh, finds the local bandwidth and the global bandwidth. With global bandwidth, mainly cluster head handles that global bandwidth, and the PDF based on the global bandwidth, and the cluster members handles the local bandwidth matrix. And then by the help of this bandwidth matrix, the global PDF is calculated, and the Pearson divergence calculated. A threshold is set to find the redundancies above the threshold. If some data is coming, then that is called anomalous or redundant data, and below that it is the normal data. And that threshold is also derived from this divergence method only. And after that, it is projected into the ELM network, which is optimal, which in which the input um, uh, input weights and biases are optimized using bacterial foraging or optimization, and it identifies those nodes which senses the redundant data, and then the normal data is fed into the base station or sync. So this is a detailed diagram in which first initially random network is deployed, and then KMSSA is uh, implemented in that to get optimal clusters and optimized cluster heads. And uh, this is the fitness function, which is like Euclidean distance of k-means clustering. It is acting as a fitness function. And to update the solve leader position, this formula is used, DJ1, which is shown, and O1 is updated by this formula. O1 is equals to 2e to the power minus 4t by n, and O1, O2, O3, these three are randomly chosen parameters, and O2 and O3 lie in between 0 and 1. If the clusters and cluster heads are obtained, then we go to the next level. If not obtained, then again that steps are repeated, that is updating the self leader position and then updating these parameters. Then once the optimized clustering is done, this probability density function is calculated on the basis of kernel density estimation. And for total estimation, the total estimation is like for each individual data, different PDF values are calculated, and then after summing up those values, we get the total estimated PDF. And as I said, that bandwidth matrix is formed using the covariance matrix, and it is updated, and the global bandwidth is used for it is handled by the CH, and on the basis of it, the for a Pearson divergence is formed as a difference between the PDF of two different data points. And DPE, it is the basis of calculating the threshold. Lambda is the threshold. And after this, the ELM is fed with this parameter, with this data, and it is trained, and the different steps of BFO is applied on that. That is chemotactic step. First is chemotactic step, then this formula phi I R plus 1 QP, this is used to for updating, and then p is equals to p plus 1. That is the elimination parameter, elimination dispersion loop. It is executed, and it gives three. It first it first it it takes the condition p less than ed. If it is true, then it enhances q is equal to q plus 1. Actually, this q is the actually this q is r is the reproduction parameter loop counter. q, r, and t are the counters, and these are incremented as the step enhances. So initially p is tested, that is
Pallavi, Pallavi, what I feel that there are two edges going to the box q equals to q plus 1.
yes sir.
And then when it happens, then what is the flow? From where
Sir,
you will start? From
sir,
step 1 or 2 or 3?
Sir, when this reproduction loop is incremented, then after that the parameters of ELM are this optimized parameters are given into the ELM.
Okay, fine.
So initially we are doing we are initializing all the loop counters, that is elimination dispersion loop. It is represented by p, reproduction is q, and chemotaxis loop is r. And after that chemotactic step is executed. In that we will define the fitness function, and this f fit IPQR is equals to 1 divided by 1 plus ERMS. This ERMS is the mean square error for training data. Then next, for generating vector, this del of I is generated using this formula, and it symbolizes ith bacterium at Rth chemotactic and Q productive and Pth elimination dispersion step. So after that, the elimination dispersion step is incremented. P is equal to p plus 1. And then this P is tested with ED, and this ED is actually the symbol for number of elimination dispersal events. After that, once the bacterium is eliminated, then it gives the optimization space, and after these two counters are incremented, R is equal to R plus 1, and it is if this q less than r, it is correct, then r is incremented. Otherwise, it will again go to the elimination dispersion step. It means that this is over. This bacteria will be died. And in this in last step, r less than c chemo, in this the ELM is trained, and we will get the optimal parameters. So this is the repetition. This is the detail for KMSSA. This is about Pearson divergence to classify the redundancies. This equation I have used.
I think this all you have already explained in your flowchart.
Yes, sir. I have already explained. Yes, sir.
Don't repeat the same.
Okay, sir.
Go to.
And this is the training and testing phase of VFO ELM. And this network is fed into the ELM training phase, and by the help of hidden layers, we are identifying the redundant node. So this is actually this is the description of data set which I'm using. 3 data set here I'm using. Air quality data set, condition monitoring of hydraulic system data set, and swarm behavior. And I'm using 75 and 25% of data for 75% of data for training and 25% for testing. This is the using the threshold values, how the divergence is working. This is shown in these diagrams. So Pearson divergence, as it is clearly seen that redundancies are much at the upper level than the threshold, and they are not coming in the way of normal nodes. They are not. They are distinctly. It is visible. So it is giving good result. Pearson divergence and KL divergence. It is also giving moderate result. But in this Rennie's divergence, some redundancies are coming in between the threshold values. This is the comparison of training and testing accuracies. I have used two. This reference number 2 is actually for ELM, simple ELM, and MELM is 5. 5 number is the MELM, that is Mahalanobis distance based radial basis function ELM, and this is my proposed. So this for a different hidden number of hidden neurons, I am calculating training accuracy, which is high for the proposed in all 3 data sets. For all 3 data sets, this testing accuracy is also high for my proposed algorithm, that is 0.92, 0.95 and 0.97 for 3 data sets. And in for testing, number of testing errors, my proposed algorithm is having very less errors. These are the results for accuracy, which show accuracy, false positive rate, and number of alive nodes and energy expenditure. And this it is in first accuracy is compared between my proposed method, then divergence using the Rennie's methods, and divergence using KL method. My proposed method is using Pearson divergence. So same for false positive rate also. Accuracy, my proposed method, it is showing accuracy in between 81 to 95%, and for Rennie's it is between 65 to 87%. This whole thing is for dataset 1, and for KL divergence it is showing between 66 to 86%. So my proposed method, it is showing better accuracy than other. And in the false positive rate, as the less the false positive rate, the better it is. So in this case also, we can clearly see that for my method, the false positive rates are very less, and active number of alive nodes are also high for my method. And MELM is the, I told, Mahalanobis distance based radial basis function based
Pallavi,
ELM, and PNND is the
Pallavi,
yes, sir.
yes, almost 50 minutes are you are have taken 50
Yes, sir.
minutes. I think you should conclude now.
Yes, sir. I am about to complete. PNNDA is the perceptron neural network based data aggregation, and LEACH is, everyone knows, low energy adaptive clustering hierarchy. So these both results, alive nodes and energy expenditure, are they are compared with these 3. So it is clearly seen, and it is for dataset 2. Here also same case. For first, my accuracy is high. FPR is also very less, and number of alive nodes high, and energy expenditure is also very less. In for dataset 3, the same comparison I have done between these same state-of-the-art methods, and this is the conclusion. So my results are showing about 10 to 30% reduction in the utilization of energy, and 80 to 95% increase in accuracy, and the false positive rates are very low, like they are around 0.4 to 0.8, and these are the references. Thank you.
Okay, fine. Any questions?
Okay, Pallavi, can you go to slide number 20?
Yes, sir.
For data set 1, I think, right? So,
Yes.
so can you comment on this energy expenditure, especially for the number of iteration between the 18 and 100? The other methods are having some type of the linearity, and in your case, it is just less linear or nearly constant in terms of energy expenditure. So can you comment on, especially between number of iteration between 80 and 100?
Between 80, yes, sir, it is coming. Yes.
But it is
So
more.
actually, sir,
it is
it
less
is,
linear or
yes,
almost
sir.
constant. We can see here.
Yes, sir. Yes, sir. It is almost constant for higher number of iteration. Yes, sir.
But in case
But
of other
not
methods,
almost content, slightly only, sir. But it is
Okay.
increasing, but at a very slight rate.
So can you give the justification? Because in other methods, it is just linear or it is more than linear. It's just linear relationship.
Sir, it is because of, sir, as the number of nodes also increases and as the number of repeated iterations are increasing, so the optimization is performing well and it leads to the stability of the system. So for more iteration, the system, the training accuracy increases, and it depends on the accuracy that energy expenditure reduces. Not reduces, it reduces at lesser rate.
Okay.
It is because of optimization.
Okay. ठीक. Okay. Or from my side, any other?
It's okay from my side. We can continue to the next presentation.
Okay, sir. Okay, Pallavi.
Yes, sir.
Thanks for a good presentation.
Thank you, sir.
So now we can call our next presenter, Manabhanjan Pradhan.
Yes, sir.
Paper ID is 194. And the paper title is Remote Authentication of IoT Devices Based upon Fog Computing. Am I correct?
Yes, sir.
Please go ahead.
Manabhanjan ji, are you facing any difficulty? Are you there, sir?
Am I audible, sir?
No. Yeah, you're audible.
Yes.
Yeah, sir.
Let me go again.
Sir, I cannot share my screen.
Yeah, right has been given to you. Right has been given.
Yeah, okay, sir. Yeah. Can you see my screen, sir? Is it visible?
Not yet. Not yet.
So now?
Yes, now fine.
Yeah.
Yes. Go ahead.
Yeah.
Presenter is requested to take care of time also.
Yes. Okay. Good evening to one and all. My name is Manabhanjan Pradhan. My paper title is Remote Authentication of IoT Devices Based upon Fog Computing. So these are the table of my table of contents. First, I'll introduce about some of the basic terminology. Then I'll go to literature survey, then motivation, proposed work, results and discussion, then conclude the paper. Before going to the paper, I just want to say about what is IoT. IoT is Internet of Things. Basically, if a device is connect through internet, the interconnection is known as Internet of Things. It was first proposed by Kevin Ashton in 1998. Second is blockchain. It is a chain of block that contains information. It was the blockchain was first introduced by Satoshi Nakamoto in 2009. It says it is a distributed ledger that is completely open to anyone, and all the nodes can verify any transaction happening in the network. So what is its major advantage? Its major advantage is if some data has been recorded in the blockchain, it is very difficult to change it. So the next one is my literature survey. Baga et al. On 2016 has proposed a paper for industrial IoT platform. It was used in public blockchain was used. Then Adori introduced IoT architecture where they have used private blockchain, and the simulation was done. Then MRuta proposed a paper on service-oriented architecture. Again, their blockchain was private. My paper was base paper was based on MT Hami. I have shown my results based on MT Hami, whose main objective was authentication, where they have used ECDSA, elliptic curve digital signature algorithm. It was public blockchain was used, and their implementation was there. DC Nguyen has proposed their paper where they have shared electronic healthcare records sharing system. Their blockchain was also public. Next, Umar Khalid and M. Tahir paper was there. They have done their paper on authentication also. Next, my problem description. So since the evolution of with the help of internet, the IoT devices are projected to amount 30.9 billion around 2025. It is a sharp jump from 13.8 billion units that are expected in 2021. So the number of IoT devices has been grown drastically in the last few years. And since this drastic change, this rapid growth, there's a tremendous increase in the cybersecurity attacks, such as ransomware attacks, such as meet in the middle attacks, Sybil attack. So to minimize those attacks, to remove those attacks, blockchain can be used, because its property is like if somebody is authentic in a node in a blockchain network, he cannot change the whole blockchain until all 51% of the nodes are with that node. So that remain unchanged property, that is immutability property, with the help of that we can authenticate the IoT device. So this is my system model A, where I have taken fog node controller. The fog node controller is to be trusted. That's my assumption. And fog node controller is connected with different fog nodes. These fog node controller and fog nodes are Ethereum based. In our project, in our proposed model, we have used Ethereum based blockchain. So these all are Ethereum based blockchain. So the next, the one fog node is connected to different users, and those users are also Ethereum based blockchain. They are connected to Ethereum based blockchain. And next is IoT device. So IoT device directly interacts with users. It cannot directly communicate with fog node or fog node controller. So this is the system proposed system model. The participants in our proposed model are fog node controller, fog node, admin, user, IoT device, where admin and user basically are the users devices, where admin has special privileges, but users has some restricted privileges. Users do not have all the privileges, except that admin and users are user devices. There are three phases in our proposed model: initialization phase, authentication phase, and communication phase. In initialization phase, first it will check. This is the algorithm for fog node registration. First, the fog node controller should be there and it should be in active state. If the fog node controller is not in active state, then the fog node cannot be registered. So if the fog node controller is active, then what fog node will do, fog node will create an ID. We have created the ID with the help of MAC address and the static IP address. The fog node will create the ID and it will send to the fog node controller. And if the fog node controller is active, then fog node controller will collect the ID and it will store the ID in blockchain. It will generate a certificate and transfer the certificate to fog node, to the respective fog node, and that certificate will be used in authentication. The second is user device registration. For a user or an admin to register, it will need a fog node. So if a fog node is there, authentic fog node is there, a user ID, a user has to send his ID to nearest fog node. It will send its ID, which is encrypted with the fog node's public key. It will send the ID encrypted with fog node public key. Fog node will get the ID, decrypt it, and it will generate a certificate, and ID and certificate will be stored in the blockchain. Now this certificate will be sent to user or admin using the public key of user or admin, and that certificate will be used in the authentication, user authentication later. Similarly, for IoT device, first IoT device has to send a request to user that I want to register in this network. Then IoT device will send its ID to user, and user will send that ID to fog node. And similarly, like the user registration, fog node will generate a certificate for IoT device, and it will store that certificate and ID into the blockchain, and then that certificate and ID will be sent to IoT device. And it will send the ID and certificate to IoT device as well as the user or the admin. The next time IoT device, when it will be authenticated, the user can authenticate that respective IoT device. The next is fog node authentication. The IoT device, user, admin, and fog node are registered. For the authentication, if a fog node wants to authenticate, the fog node controller should be in active state. If the fog node controller is not in active state, the fog node cannot be authenticated. So what will fog node do? Fog node will send the ID and certificate received in the algorithm first to the fog node controller, and fog node controller will collect that ID and certificate, and it will send to the blockchain. If the ID and certificate are in the blockchain, then it will be authenticated and it will be connected to the network. Similarly, user will send its ID and certificate received in the algorithm to the fog node. The fog node will check whether that ID and certificate is in the blockchain or not. If the user is authentic, its ID and certificate will be matched, and they will be authenticated to join the network. For IoT device, first the IoT device will send a request to user, and user will send a request to fog node. If the fog node is exists, and if the user is user is authentic, user is there, then IoT device will send a ID and certificate received in the algorithm 3, and that will be checked using the blockchain. If the IoT device is authentic, then it will be joined in the network. Next, when IoT device, fog node, and users all are authentic, then a device can communicate. In our proposed model, we have checked whether the request is malicious or not with the help of signatures, predefined signatures. If those signatures are like, if they are like in malicious in nature, then the IoT device cannot communicate with other devices in the network. These are the results which we have seen. Our proposed model has given the better performance using MT-Hamid. The time required to generate a registration request, the average time to generate a registration request is 1.56 in MT-Hamid. In our proposed model, it's 1.44 millisecond. Similarly, the time required to generate the data message on average in MT-Hamid is 0.04. In our proposed model is also 0.04. Then next, the power generated to generate the registration request in MT-Hamid is 9.76, and on our proposed model it's 8.00. The power needed to generate data message is 3.35 in MT-Hamid, and in our proposed model it's 3.10. We have proposed a remote authentication of IoT devices, which is based on fog computing and blockchain. So in our paper, we have shown it can withstand both passive and active attacks, such as Sybil attack, spoofing attack, man-in-the-middle attack. And it has been compared with some component schemes like such as data integrity, availability, and mutual authentication. So that's in our paper. These are the references, chosen references I have shown here. And any questions?
Yes, any questions?
Can you go to slide number 17?
Yes, sir.
So how this power is calculated? Can you tell me about something? What formula you use to generate this power?
Sir, there is this library RPCL was there. I have used that library to generate. I will just run that program and it will calculate that power.
Okay, so
And
is
it will be
any
shown.
theoretically, mathematical or any formula so that we can confirm how this power is calculated?
So I just use the library function to call that power, and I have like used thousands of requests, and I averaged them and then calculated this.
So same library may have been used by other references. Can you sure
Yes,
about
sir.
it?
Yes, the MT-Hamid paper has used the same library that so it can be used. It's a C++ library.
Okay, okay, okay. So over from my side.
Okay, so
Manamanjan?
Yes, sir.
Yes, sir. Please go ahead.
Yes, sir.
actually, all these things like you are doing theoretically is how feasible is to implement all these techniques?
So I have implemented this on my laptop and on the Raspberry Pi also. But the I have shown only the laptop results here. I just compared it with MT-Hamid and shown here. I have implemented this thing.
Like consumption of power is a major factor in these blockchain technologies. So how this can be justified using, like you are calculating through built-in library functions? That depends on like architecture and the machine itself.
Yes, sir. Sir, for that purpose, since I have to use blockchain, that's why I have used Ganache That's a Ethereum based IDE where I have created the smart contract, and it will communicate. That smart contract will communicate with my program and with blockchain, the Ganache. And I have used that for our simulation.
Why you used Ethereum based? Like there are others technologies also. Is
Yes,
there
sir.
any
Sir,
established comparison between them, or any specific reason behind
yeah,
your?
sir. I have taken the concept of, I've seen the Bitcoin also, a Bitcoin smart contract and Hyperledger Fabric. But since it is in a developed stage, Ethereum is the most used blockchain right now. Till date, it has many developers, and they are like active in Ethereum also. But in Hyperfabric Ledger and or PBFT, like Byzantine fault tolerance, they have limited developers. So that's why I chose Ethereum, because if I need some like if I stuck in somewhere, I can contact them.
Okay, fine.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, Manamanjan, I am having a very small question. In your proposed architecture, what has been, realized as user, whether it's in a device or it's in software, where it will be in the system exactly?
So it will be any user like us. Like I have a mobile, I can be a
Yes.
user device. My mobile will be a user device, and I can communicate with any of the participants in the network. If I am a printer, then it will be a IoT device. And suppose I am a user, then I want to access that printer, then I will be the user and I can use that printer.
But obviously, printer is a passive device. Printer cannot transmit data by its own. As far as IoT devices are concerned, they have to. As far as IoT devices are concerned, they are supposed to be equipped with sensors. And when the environment changes, the actuator is actuated and the data has been sent actively. So that was my point on it.
Yes, sir. Yes, sir. I got the question. For IoT devices, like you said, the sensors were used. For my practical implementation, I have just chosen IoT devices as like mobile devices or the Raspberry Pi or the printer for that purpose, because that
Okay,
will
fine.
Yes, sir.
Okay, Mahabanjan, your idea is good. I'm not saying your idea is not good, but I would like to, you put effort in a direction where this could be applicable. When we talk of IoT, we are talking for application. Let us say we have deployed various sensors to capture the humidity of the environment. And obviously the sensors are going to continuously send the humidity level to the system itself. And that data needs to be protected through blockchain, as you are saying. So I think that should be included in your future work. As far as this work is concerned, nice presentation.
Yes, sir.
Any other question?
Actually, sir, yeah, actually, sir, I am working on Internet of Vehicles also, and I have developed that part also, where Internet of Vehicles, I have created an authentication system where requests are sent from vehicle to the RSUs and vice versa. I'm doing that, sir.
Okay, fine. That's good.
Yes, sir.
So, sir, with all permission, we can move on to third paper.
Yes, sir.
Okay, fine. So we have our third paper, which will be presented by Dr. Gyaneshwar Singh. Paper ID is 377. Paper topic is an efficient ECC-based authentication scheme for IoT. Gyaneshwar Singh ji, you can continue.
Good evening, sir. Am I audible?
Good evening. Yes, you are audible.
Okay, sir. Is my screen is visible, sir?
Fine. Go ahead.
Hello, good evening, everyone. Myself, Ganeshwar Singh. I'm from Chandigarh University, Mohali. My today's topic is an efficient ECC-based authentication schemes for IoT device. Here are the tables of content which I am going to talk about. First, we are going to talk about the introduction about it, complexity assumptions, literature survey, problem description, methodology, result and discussion, conclusion, and references. When we come towards introduction part, we talk about the background. ECC. ECC is an elliptic curve cryptography, which is a key-based techniques for the encryption and decryption of the data. It mainly focus on the pair of public and a private key for the decryption and the encryption. As we know, before the ECC cryptography was introduced, before that RSA was there, which had a lot of problem with the related, such as with the size of a cryptography and the amount of time it takes for the encryption and the decryption. With the help of elliptic curve cryptography, it helps us to reduce the size of a paired for the private key as well as our public key, and it also helps us to increase the security of the both the keys for the in the process of encryption and the decryption of the data. Here I have given the definition about the elliptic curve, how the elliptic curve is there. Then I have talked about the point addition and the point doubling. In a point addition, when the 2 points are at in the region of finite real places and how they interconnect with them, and doubling when the 1 point is at the one surface and another surface. Next, then we come to the complexity assumptions. First, elliptic curve discrete algorithm problem. It is a special case of a arithmetic algorithm problem, in which a group is represented by the group angle, a point on an elliptic curve. As you can say, it is given P and Q are the element, and it is hard to find an integer k within a z of P, such as P equals to kq. Then we come to the elliptic curve computational Diffie-Hellman assumption. Here it is a key agreement protocol that allow two parties each having an elliptic curve public and the private key pair to establish a shared secret over the share the data over the unsecured channel. Whenever the channel is unsecure, it helps us to transfer the data in a protected manner. And the third, we have a elliptic curve decisional Diffie-Hellman assumption. Here it is a basic of a it is the basic of proof of security of a encryption protocol, which help us to introduce help us to maintain the security level inside it. Here I have just talked about the 5 of the paper of my original paper references. And the first, in 2017, the PK has presented a 3-factor mutual authentication technique to address one of the most pressing security channel in the IoT paradigm. In this technique, however, is valuable the security flaw and the very verification time and the memory uses are both high. In 2019, S. Dubé proposed an authentication protocol using a public cryptography, but his protocol has a high computation cost and does not resist the offline password guessing attacks. And again, the F. Wong in 2019 itself proposed the biometric based authentication scheme that does not have anonymity and has a high computation cost. In 2021, M. Sumit proposed, sorry.
Yes, continue.
Okay.
There was an echo. It is
okay, sure, sir. Propose a 3-factor authentication scheme, but his scheme does not resist a perfect forward secrecy. In 2021, QZ proposed a 3-factor authentication using the ECC and the fuzzy extractor algorithm, which not only defend against the network's attacks, but also defend against the informal security analysis. He also simulated a design scheme for its formal security verification using his ProRIF tool to prove the security. Mainly through this literature review, I just want to show all the authors were talking about the computation cost and how much time it takes for encrypting or decrypting any message, and whatever the protocol they were using, how good was there, and how much disadvantages they were having. So to come in our problem description, here we talked about the majority of existing authentication schemes for the IoT network are not entirely secure against the security attacks. As we know today, in today's era, security is a main problem which is being handled in most of the IoT devices. Most of the IoT devices get hacked because of the low in security. So to increase the security level, we try to implement it. Many schemes were not able to provide a greater efficiency in terms of computation cost. As we talk about, it takes a lot of time to implement that particular algorithm. It takes lot of time for, and the efficiency is not so good. Because of that, its computation cost also increases. Our main focus is also to overcome the issue. We design a reliable and efficient and effective authentication schemes for the IoT. We propose the ECC-based mutual authentication scheme for the IoT environment to address the many security concerns such as privacy, reliability, and the data protection. The security analysis reveals that the proposed scheme can withstand several well-known attacks. Here we come to methodology. In our proposed scheme, we have we have talked about the two phases, such as registration phase and the authentication and control phase. In the registration phase, we have two phases, two subphases, as a server registration and the user registration. In the user, as you can see in the user registration, whenever the new user registered, he will be provided with the his private and the public key, which he can use for the communicating in the server. And whenever the new server is introduced in the environment, it will also be having his identity, which will be stored in the memory. Here is our authentication and access control phase, where we talk about the authorization and the authorization and access of data. Whenever the two users interchange the messages or a data within themselves. So how it will work? The first they have to share their public key, and then according to that, the work will be going on. Then we come to the result and discussion. Our main focus was here to increase the security. So for that, we did a security analysis. The security analysis for the authentication scheme is essential for any IoT network, as the multiple identical authentication techniques already exist, which has been employing the ban logic to prove the security. But future research shows that none of these technology fulfill the needs of a security feature. As you can, mentioned in below the table, we have compared our proposed scheme with the three different paper. I have given the references at the last about them. So the first was there, the main in a middle attack, like in between, whenever that there is a transfer of a data in between, the third party attacks were there. So it could be secured by all the proposed schemes, and as a relay attacks can be achieved. A stolen card attack could also be solved. Anatomy, which could not be solved by one of the paper, and offline password guessing attack was also a major factor, which was also a part of security failures in one of our paper. And perfect forward accuracies also is there, and inside attackers, like whatever there. We imply the informal approach to verify the suggested scheme security and demonstrated that it can withstand the schemes to other comparable schemes. Here are our results and discussion. Basically, during our making a proposed scheme, we have used the several techniques like elliptic curve point addition, elliptic curve point multiplication, one-way hash function, symmetry key encryption, and or decryption, and modular exponential operation. So for to find the how much time each algorithm takes, we find that time about them. to see the what are the time complexity we are facing. We have considered these results to compare the computational cost for the user and the server registration. As you can see in the below table, the computation cost comparison. We have taken the same schemes, same papers, and we have taken their scheme also and compared that scheme with us, which was much lower than them, which help us to provide the better proposed scheme, which could reduce the computation cost and increase the greater efficiency. So here you can see the graph about the computational cost comparison between the two other schemes with our proposed schemes. Finally, in a conclusion, we have proposed the secure authentication scheme that is based on ECC. We examined the design of a multi-server authentication scheme using a smart card. Due to its complex of balancing security and efficiency, proposing a two-factor authentication scheme that provides a multiple security aspect while keeping an adequate performance remains a challenge. The suggested scheme is evaluated informally to ensure that it is resistant to various security attacks. The suggested scheme is computationally efficient compared to the other comparable schemes, as we have shown in our results. Here are the few references which I have taken and which I have used in for my proposed schemes, as well as the comparison of cost, computational cost, and their efficiencies. Thank you.
Yes, any questions?
Hello.
Yes, sir.
Is there any relationship between the security attacks and computational time?
Yes, sir. Yes, sir. So you are talking about the security and the computational cost, no, sir?
Yes. Computational time and security.
Yes, sir. Computational time, like how much time it is taking for the processing part. So if the time of processing is it will reduce, then it will also give a less time for the attackers to attack in our protocol. Like if the computation cost is high, which means that it is taking a lot of time to build that performance. So during meantime, anyone can attack on this proposed scheme, na, sir. So to overcome all these things, we need to have a low computational cost.
Okay. Okay.
Okay, sir. Thank you, sir.
Okay, any other
Okay,
questions?
so what were the advantages of ECC over RSS?
Sir, RSS was having a greater size because it takes more bits compared to the ECC, and it also does not provide a it does not provide a good security, as it is taking a lot of storage capacity also, and our storage will also increase compared to the ECC. ECC will be having a small 3 or 2 digit number. So so it will be very hard to take it on.
But still, RSA is most widely used public key crypto system nowadays also.
Yes, sir. But
What are the
RSA,
reasons? You have listed a lot of drawbacks actually. So what
sir,
makes RSA useful actually?
Sir, RSA, see, because it is previously introduced a long time before. So during that time it has a lot of advantages. But the ECC is recently introduced, so we are still doing researches how it is more efficient than the RSA, sir.
Okay.
Yes, sir.
So actually, you have used ECC for authentication purpose.
Yes, sir. Yes, sir. Authentication purpose.
So like to authenticate a device or authenticate like message or some content or information.
So it is just for the we have done this for the registration phase. Whenever the new users come to the any IoT environment. So for that, users registration with the server and within the environment only.
So how you will authenticate? Somebody is trying to enter, trying to get access of your server.
Okay.
There should be some communication from that side. How you will get to know whether it is an authentic person or not?
Sir, with the help of their public keys, like their hash value will not be similar, same, na sir, because the.
But it is actually trying. A very first time I'm trying to enter into the server. I don't have any like previous connection. So how I'll be getting the hash value or everything, whatever you are talking about?
Sir, during the registration only, na. So whenever your unique digital ID will be generated, with that you will be provided the public key and the private key, which will be having a different hash values, because it is because public key and the private key never have.
Okay, just answer one question. To provide the authentication, like identity is encrypted by public key or private key?
So public key.
And what if I encrypt it using private key and decrypt using public key? Which kind of service it become?
So
okay, no problem. No problem. Okay. Okay from my side.
Okay, thank you.
Any other questions? Okay, Ganeshwar, I think we are done.
Thank you, sir.
Thank you for your presentation. And I would like to welcome Dilip Singh Shisodia sir is there, and Pradeep Singh sir is also joined. Congratulations, sir.
No, welcome from our side for sparing valuable time for this session.
It's my pleasure that I have been the part of this good event and very prestigious event. So
Thank you,
it's a very good.
Sasi, sir, for sparing your valuable time and conducting such a nice session in a nice way.
Yes, sir.
And I also thank Dr. Ramcharan Gurjar as well as Dr. Gyan Singh Yadav. Yeah, no, sir, we are in the meantime. So we can take next one.
Okay, yes, sir. Sure. So we are having our next presenter, Dr. R. Sajeev Krishna. His paper ID is 382 and his paper title is Intelligent Smart Waste Management System using Mobile Application and IoT. Dr. R. Sajeev Krishna, are you there?
Sir, yes, sir.
Or any?
Am I audible, sir?
Yes. Yes, you are quite audible. You can share your PPT and start your presentation.
So, look past.
Yes, R. Sajeev Krishna, your voice is not coming. You are not audible. Please check your microphone. Mr. Sajeev Krishna, am I audible to you?
So actually he's muted,
sir, am I audible now, sir?
Yeah. Now
yes, you're
clear.
audible. Yes, now you're audible. Yes.
Yes, sir.
Please go ahead.
Good morning, sir. I am Sajeev. So my topic is an intelligent smart waste management system using mobile application and IoT. So in India, the most common problem that we are facing every day is waste management. So even though it is 5 to 6 years since the Prime Minister has launched the Swachh Bharat Abhiyan, we have not achieved a complete self-sufficiency in terms of waste management. So this is a common sight in all cities. So stray animals like cows and dogs all keep eating from the waste from the dustbins, and the waste is always overflowing. So this is because of the poor waste management practices followed in the municipality. So this is the literature survey. So in all the previous researches conducted by the researchers, so the most common approach that they follow is they send the current waste level in the dustbin to a mobile phone through an SMS through GSM technology. So, but they do not focus on aspects of eliminating animal contact, and there is no mechanism to make the waste collection process more effective. So, and some researchers have also used convolutional neural networks and machine learning. So this is my problem description. So we have implemented an intelligent solution using IoT device and an Android app in order to speed up the process of waste collection and to simultaneously eliminate animal contact with the dustbins. So this is the solution architecture. So as you can see, so this architecture is distributed in nature. So there are four main entities. So one is the IoT smart bin, and the other one is the mobile application. So the mobile application is used by the municipality workers. So they are the sanitary workers who clean the dustbin periodically. And the other one is, and the other entity is a mobile application. So they are being used by the citizens and the common public. And the next entity is a server. So the server, the main function of the server is to act as an interface between all these other entities. So I have implemented a REST API within the server so that it can receive data from multiple devices. And the REST API of the server sits in front of the database. So the database primarily stores user information like account information and the current waste level of the dustbin and other data. So now I will detail about the IoT module. So the IoT module contains the Arduino component. As you can look at the schematic diagram in the right side, it contains an Arduino component. The Arduino is used as an interface between the other three sensors. So the sensor on the rightmost side is the ultrasonic sensor. So it performs a dual function. It detects the waste level of the dustbin, and it is also used to repel the animals. And the sensor in the middle is the GSM module. So it is used to send HTTP requests to the REST API. And the sensor on the left is the proximity sensor. So the proximity sensor detects whether there is an object situated near the dustbin. So the flowchart on the left side depicts the functioning of the IoT module. So the proximity sensor, as long as the dustbin is connected to the web server, that is the REST API, the IoT module keeps working. So the proximity sensor detects whether there is any object in front of the dustbin. So it also detects humans and animals. And if it detects an obstacle, it emits ultrasound using the ultrasonic sensor. It directs the ultrasonic sensor to emit ultrasound. So the frequency of the ultrasound emitted is 40,000 hertz. The sensor used is HC-SR04 sensor, and it detects waste, and if there is no obstacle detected, it detects the waste level and it sends the data to the GSM module. So as long as the obstacle, it may be either a dog or a cow or a human, it keeps emitting ultrasound. So in case if it is a cow, cows, as we know, cows and dogs are sensitive to ultrasound. So humans have a hearing range of 20 hertz to 20,000 hertz, but so dogs can hear more than 20,000 hertz. So this principle is used in dog whistles too. So we have used this, we have applied the same principle here. So dogs are sensitive to ultrasound. So as soon as they hear it, they immediately move away from the dustbin. So the same logic applies for cows and other animals like monkeys. And this is the mobile app. So I have attached the individual pages of the app. So it also, the mobile app, other than displaying the current level of the dustbin, it also has extended functionalities like detecting the nearby dustbin using Google Maps. So this is particularly useful for citizens who just litter their waste here and there. So they can find out the nearby dustbin using this functionality and they can dispose it properly. And it also contains grievance form and feedback. So this can be done when the dustbin is overflowing or when any other thing is damaged. The citizens can fill this form and send it, and it will immediately be sent to the notification of the municipal department. So that's why we have attached a login form in the beginning of the app. So according to the login information which is stored in the database, the user can receive different views of the same app. So for an administrator, it will show a different view and so on. So this is the working prototype of the smart bin. So we have implemented a working prototype and we have deployed it in our institution. So this is just a small model. So we have deployed it in our institution and we have tested it successfully. So this is the test results of the institution. Uh, so as soon as a dog approaches, this test case number 1, as soon as a dog or a monkey approaches the dustbin, so the ultrasound is emitted because the proximity sensor detects it. And we have verified the result as the dog moves away immediately. And we have also done other forms of testing such as load testing, unit testing, and so on. So in acceptance testing, the sanitary workers are notified, and we have also tested it with more number of devices. So that's why we have used a web server as a REST API. So this is done because the entire application must be scalable. So in the literature survey, what the main approach they have used is they keep sending messages from the IoT device to the individual cell phone. So this is not possible. This is not feasible in case of a huge municipality. So there are multiple cell phones, there are multiple sanitary workers, and there are lots of citizens. So it is not possible to send message to everybody. So we have used a web service to make it more scalable. And we have also unit tested the app for the Google Maps functionality. And we have also collected reviews from the users through the mobile app itself. So these are the reviews that we collected from our institution, from our college. So majority of the users have approved it. So I'll conclude my presentation by saying that our project or implementation is far better than the ones in the literature survey. It is then mentioned in the literature survey. It is more simple, and at the same time, it is also effective. So these are the references. Any questions, sir?
Okay. So what is the size of dustbin you have considered for this prototype?
So the size is we have taken the standard size, sir. So this is just a small model. So in the original prototype in which we carried out the testing, we have soldered the IoT components. So the size of the dustbin that we chose was about 3 feet in height, and it was 1 feet in width.
Okay, so
So
you
this is
have
just a small model. This
it
is
it
just
is
a
for the
small
public
model,
space,
sir.
or it can be used in the also households.
Sir, this is mainly used for in the public, sir. So because only in public places we have such issues like the cows eating from the dustbins and overflowing dustbins. So the main motto of Swachh Bharat is to make a hygienic environment in the public also. So homes are always clean, right? We can
And
also use it in the homes, sir. We do not have these issues at home, right?
and what about the rainy season? In case of rainy season, your sensor may or may not work, especially in the case of.
Oh, rainy season, sir. We have, so as you can see from the model, so this is a small prototype. So in our original testing prototype, we soldered all the devices. And as you can see from the dustbin, we have placed it beneath the hood of the dustbin. So rainwater will not fall on the IoT kit, sir. So we have positioned it in such a way that it does not fall on it. So I have used a breadboard here mainly for prototyping. So, but in the actual model, we can solder it and place it beneath the hood of the dustbin. You can see, right, there's a hood on the dustbin and there's a place to drop the waste inside. So rainwater will not fall on it.
Okay, okay. Okay, so okay from my side.
Yes, any other questions?
Hello.
Hello, sir.
Actually, we have used ultrasonic sensors.
Yes, sir.
Is it right?
Yes, sir. Ultrasonic sensor.
So, like, is there any alternative of this, or this is the best in for your particular application? You are just interested in measuring the distance of like dog or something.
Yes, sir. Yes, sir. I'll explain it once more. So as I said, the ultrasonic sensor, as you can see, this is in the form of a radio. So the left circle is an emitter and the right circle is a transmitter. So this performs a dual function. So it can also be used to. It can also be used to detect the waste level, and simultaneously we can also use it to repel the animals because it emits ultrasound. So the same ultrasound is used to detect the waste of the dustbin.
Okay,
And you can also see the positioning of the ultrasonic sensor. We have positioned it on the outside, so we can simultaneously we can detect the waste and also repel the animals.
What about the power supply?
So the power supply is given only for the Arduino, sir. You can see this from the
Means how
schematic
you are
diagram.
actually in your proposal, like how it will be provided using solar or something, some power.
Yes, sir. Yes, sir. Sir, Arduino is a lightweight board, sir.
That
So
I
it
got it. Like
requires
Arduino, yeah.
it requires only 12 volt to function. So the other sensors do not require any extra power supply from the external source. So it is sufficient to give a 12 volt power supply to the Arduino using a very small battery.
So you are going to put a battery or some other mechanism to provide this.
Yes, sir. We are going to fix a battery onto the IoT kit. So, sir,
Okay, so
Arduino can
in few
function using the
after
12
some
volt
time
battery.
you shall be replacing that battery like this.
Yes, sir. We have to periodically maintain the dustbin. We have to periodically maintain the we have to maintain the dustbin by replacing the batteries when required.
Okay. Okay, fine.
Okay, fine, Sajeev. I think you people have taken a very prominent problem. And I would suggest you people should go for a patent and you should talk to the people who are manufacturer of such type of bins. Fine. Am I audible?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Okay. Because this need to be converted into a product. So you have to scale down this. The size of the work has to be scaled down to a product which can be implanted on the dustbins. So thank you very
Yes,
much.
sir.
So we
Sure,
can
sir.
move to our last paper presentation. that is paper ID 454. And the topic is an IoT machine learning model-based real-time diagnostic and monitoring system. Do we have the presenter of this paper? And yes, sir.
Yes, I'm available.
Sir, yes, sir. Please go ahead.
Okay, I want to share my screen. Can you see my screen, please?
Yes, yes, you are clear.
Yes, it's visible.
Okay. Good afternoon, sir. I'm here to present a paper, an IoT machine learning model-based real-time diagnostics and monitoring system. From the Department of Computer Science, University of Ilorin, Nigeria. These are the table of content. I'm going to talk about the introduction, methodology, results, and discussion. Then I will go to the conclusion. There is no doubt IoT-based enabled machine learning models have been in use for the processing of generated big data in order to generate reliable results that can be used by medical experts for decision-making on various health challenges. And the IoT-based system has become one of the most important aspects of people's life, resulting in the generation of huge data. The sensor we use have given us the access to generate good amount of data that can be processed by machine learning. Not even only machine learning, the deep learning has been used to process this generating data in order to be able to make a meaningful decision out of the data generated by the IoT. And health professionals are already using IoT-based sensor in disease diagnosing, monitoring, prediction, and even treatment of various diseases. The capturing of patient data in real time is made possible by the using of IoT sensors and devices. And thus, this helps us in real time diagnosis, monitoring, and treatment of various infectious diseases. Now, the paper contribution will be that we are able to propose a machine learning-based enabled IoT system framework to be able to diagnose and monitor various diseases in real time. We tried to use a data set that has been generated to try to see maybe our proposed model is work effectively or not. And these are the performance metrics that we use to test the model, the accuracy, precision, recurse, ROC, and a lot of you. And we try to compare them whether it's working or not. These are the literature we are able to use in order to come up with the robust framework we are able to create. I won't waste my time on this. Then the problem description. We try to create a framework that we use IoT-based system to generate data from patients. And after this data is being generated, we use machine learning to try to process the data, to manipulate the data, to actually see what is really happening concerning each data we generated. We process them by using machine learning to be able to come out with a decision that an expert system can use. Then the methodology we use. The methodology we use the ML-enabled IoT diagnosis system framework. The paper uses a set of interconnected variable to monitor and diagnose a patient's medical condition. The cloud server was used in order to afford using mobile phone memory, and the data was sent straight to the cloud server over wireless network. The proposed framework is what we see on the screen. This is the IoT medical device that can be used, can be anything, depend on the type of disease that you want to measure and what to test from the patient. That's why we have different type of devices and sensor, and it will pass through a gateway device. Then this is the cloud where the data will be stored. After this data is being stored, it will be sent data pre-processing, feature extraction, and some other things. This is where the implementation will be taking place after we are able to collect the data from the cloud storage repositories, and we use that. After that, it send it to the result aspect to the expert that will be able to make use of it to make a decision. Now, they will try to use two type of machine learning to really try to process this data. We use the lightweight gradient boosting machine and GB boost machine. These are the two type of classifier we use in the course of this study. The result we use on the training. Hello, sir.
Yes,
Hello,
continue, please.
Yeah, please continue.
You are
Sorry.
audible. Go ahead.
Yeah, you are audible. Please continue. Sorry for interruption.
On the training data set, two classifiers I've just explained were used. And we discovered that the XG boost classifier perform better when we compare the two. In fact, in time of the performance metrics we use, all through we discovered that GB boost perform better when we compare to the other classifier we use. And in all, it have almost more than 95%. We have for the accuracy, we have 95.7. For precision, we have 96.0. Recall 55.9, and F1 score we have 94.8, and the ROC we have this respectively. And we try to use graph tool to be able to see graphically to see the performance of the two classifier. Even from the diagram, we can see that the XG boost is better than the LGBM classifier. Now we can still use this table to be able to show the result, but the most important thing is that the XGB boost perform better, having about 90% all across the classifier we use to test the model. Then the conclusion, the results show that the classifier the best performing classifier correctly classify 95% accurately and provide a balanced sensitivities. And we propose in the future work that it is good to still use feature selection algorithm like PCA and the others to be able to try to reduce the features used to classify the diseases. So in the future, we try as much as possible that we want to use a feature selection on this model so that we'll be able to see how better it will perform. Then secondly, we said one of the problem of IoT system is security. So in the future too, we should be able to try to protect the patient data so that unauthorized person will not be able to have access to it. So in future work too, we are going to try to protect the IoT from all authorized user. Then these are my references. Thank you. God bless for listening.
Thank you, Mr. Joseph. Any questions? If there are no questions, then we can conclude this. Dilip sir, good evening.
Good evening, sir.
Good evening, Dilip sir.
Good evening. Good evening. You all are requested to switch on your camera so we can take a group photo. Who is coordinating this session?
I think
Yes, sir. All session
Deepak,
chairs are requested.
Devesh is
Devesh.
Yes,
Yeah,
sir.
Devesh,
Yes.
please can you
Mr.
take a
Joseph,
group?
you are requested to Mr. Joseph, you are requested to kindly stop sharing.
Okay, I will do that now.
Sure, and please enable your camera.
Okay, sir.
ऑटोमेटिक आ जाएगा हाँ पार्टिसिपेंट बंद करिए पार्टिसिपेंट
Joseph, you are faculty there or research scholar?
Sir?
You are faculty there in university or research scholar? You are faculty member there?
From my
You are professor there?
No, a senior lecturer.
Yeah, it's equivalent to professor. Senior lecturer is like
Yes.
associate professor in India. Yeah, welcome.
Yeah,
You both?
thank you, sir.
Yeah. You are
Happy to see you.
yeah. And
Remaining members are also requested to turn on their camera.
Yeah, we seen it. I'll beat you.
Dr. Gyan Singh. Okay, no problem. Devesh, you just take this name. Devesh, you are first unmute yourself. You are saying something, but you are muted.
So on behalf of NIT Raipur and organizing committee of conference, I thank you all for sparing valuable times and as well as providing valuable feedbacks to all the authors. Also, it's kindly requested to all the session chairs to provide their valuable evaluation mark in the Google Forms shared to them. Thank you, sir. Thank you so much.
Thank you. Thank you very much. This is today's last session.
Thank you, sir, for inviting us and giving us the opportunity to interact with all the presenters and knowing about new work which people are taking. Though it is my parent, department, I feel a
you still part of department, and anytime we can remember.
So generous, so generous of you, sir.
Well, sir. Prof.
Yes.
Please always let us know when the conference is coming up.
Definitely. You have my email ID. Who mailed me today? So please keep my email ID, and yeah, if we'll organize something, definitely we'll approach you.
Okay.
Thank you, everybody.
Yeah, welcome.
Can we leave now?
Yeah.
Yes.
Sure. Thank you.
Thank you, everyone.
Thank you, Dr. Jairam.
Thank you, sir. Thank you.
Yeah, you did a lot of support in conducting all these sessions.
Yeah, thank you, sir.
Yes, sir. Thanks to all the team, Dr. Jairam, sir, Dr. Veena, Anand,
Sir.
Deepak also there.
Sir,
Deep
thank
sir
you.
is there.
First, we have to say thank you to you for accepting our invitation.
Thank you, Professor Gurjar.
Yes, Ramchandra is there. Fine.
It was a well coordinated.
Professor Gurjar did a lot help in reviewing the papers.
Yes.
It is all because of you people we are able to organize such conference.
Yes.
Your support is highly appreciated.
Okay.
And sir, our best wishes for organizing the same next year also.
Yeah,
Definitely.
we'll try. Right now we cannot commit, but after some time, yes, we can do.
Corona is gone now. Probably,
Yeah,
probably we can.
next time we will